I guess I've heard several questions about where are the applications and so on. And Mike talked about the fact that it is an interesting thing to transition from science application to business applications. And that's where many of my interests lie. So that's what I'll be talking about today. So feel free to ask me questions as we go along. So basic outline is I want to talk to you about a center we are developing for large-scale live analytics and smart services, very much along the lines that Masood and Frank have mentioned. And I want to give you a little bit of a sense of the research thrust that we have and some illustrative projects. And I want to separate out or distinguish between enterprise-oriented projects and web company-oriented projects. And then I want to focus on the specific problem of looking at advertising problems when you want to dynamically attribute what is the impact of any given campaign that have many campaigns going on the actual commercial actions. You want people to buy things, right? So you keep showing them different advertisements. So which of these campaigns is effective? But the same ad can be shown by Yahoo, by Google, and others, right? So, but which one should I give credit to if somebody actually bought something, right? That's the problem I want to talk about. Very quickly, just about the center, since Mike is here, I think of AmpLab as infrastructure, right? You have the platform. And I sort of think of the work we're doing in the center class for large-scale live analytics as really the analytics and applications component of flavor, if you will. And so just to give you some sample topics, how do you fuse, this is something which came from the CFO of Tesla, saying how do you fuse information from multiple sources, right? If I have Facebook, Twitter, and so on, I'm trying to sell things. And apparently a lot of academics, surprisingly, buy Tesla. You wouldn't expect the academics to have money. So the question is, how do you fuse multiple sources of information so I can really drive my marketing and sales or even engineering? Or the other question is, hey, right now it's a greenfield start. I'm developing completely new technologies, but a year from now I'll be doing revisions. So how do I capture all this knowledge so that I can reuse it, right? By the way, this second part is something we've been working on with Cisco, which I'll show you, for which we just received the Best Paper Award for the SRI conference last week. So by the way, we've got partners from multiple campuses, not just UC, of course. I'm glad Mike is here. A bunch of people from Berkeley, Santa Cruz, San Diego, Davis. We are looking at healthcare and so on, Stanford and so on. So just in terms of research streams, when I think of the sort of work that goes on, much of my earlier work was to do with big companies like SAP, IBM, Cisco, the enterprise companies. And then, more recently, I've been working with companies such as AOL Advertising and even smaller ones such as Serendio. I'll show you what they do in just a moment. Well, I guess, and then you'll see some examples. And there are interesting differences both in terms of computation and the type of problems you tend to think about in these situations. Okay. Now, so let's start with web. It's sort of more fun, right? So AOL, which I'm going to describe to you a little bit more in detail, is really about, hey, are marketing campaigns effective? Simple question, right? So because what happens is AOL is a company which stands between advertisers and publishers. So advertisers want to publish their wares on the publisher pages, right? But they don't quite know how to do it right to make money. So AOL is the company, AOL advertising.com component of AOL is the one which helps them do it. So the whole goal is, and I'm going to show you, how do I figure out from looking at ads, looking at the business actions such as purchases that customers make, how can I predict which campaign is more effective than others, right? That's the type of problem we're talking about. So bullseye versus just broadcasting out, right? That's what we're talking about. Now, Serendio is an interesting company where they want us to look at a whole bunch of social media websites and they want to predict commodity and stock prices. We're just getting started. We'll tell you how successful we are, right? AOL, we've made some progress. CrowdScience is another interesting company. I'm sure many of you are familiar with Core Metrics, acquired by IBM, right? So the whole idea is when you look at publishers, they need help to figure out when users show up, how much time do they spend, what do they find interesting, all this sort of information, because then they can market themselves to the advertisers to say, hey, pay me more money. So CrowdScience is very interesting. So the question, of course, is these companies not only look at customers coming passively, but they actively ask people questions, survey questions online, and they have to choose which of these guys do I ask a question to get the most informative information. So these sort of problems to get the most effective feedback. So that's something we're working on, which is part of active learning and machine learning. right? Now, Claritix is a very interesting company because all of you know, not just kids, but everybody's playing games, right? And serious games too. Social media. Well, this is a company which actually helps social media game companies to optimize their performance in advertising. So we're beginning to look at what sort of user preferences are there and how do you really optimize campaign effectiveness in social games. Okay, that's on the web end. On the enterprise end, with SAP, we are looking at, think about it, right? You go to a search engine, and I think there are lots of questions about Google. But very often, we aren't very happy with the performance of these search engines, right? Because you keep interacting with the search engine, it keeps giving you all sorts of baloney results. So our whole goal here, working with SAP, is how do you really come up with much more powerful results so that the engine starts learning better what your intent is, which is on the right-hand side. And so you go from informational and generic questions to very specific questions you have interest in. And any one of you who wants to stay back after that, we have developed a search engine which I can give you a little demo offline. So that's the big push here. And notice that the interactive search is also based on topic-guided search, which is crowdsourced and personalized. So that means, I think you had a question earlier on, right? Do you have effective topic modeling? I'll show you an interesting example from security. And now finally, Cisco, we've been working with them on, where I've got 100 documents, millions of documents, hundreds of pages, lots of garbage and gobbledygook. How do I winnow the very valuable knowledge resident in it? And that's a project with Cisco. So just to give you a quick feel. Now, last question is, in the center, the concept is, there are lots of hammers we academic like, but often maybe the problem is something that needs a wrench than a hammer, and so we'll develop one. Okay, let's see here. So what's the problem here in AOL? So as I said, the motivation is about campaign effectiveness, and online display advertising is a huge area of growth, right? Now it's beginning to rival search. Most people do sponsored search, but advertising is a big area as a marketing channel. So often people look at an advertisement online, and they may go buy in the offline, actually, in the store or something. So the big question becomes, thinking is triggered by online advertising. We can also be exposed to ads. The same product may be advertised through Yahoo, Google, and so on. So how do we know that when users perform or convert, either at the website of the user or somewhere else, how do we really relate the actions of purchasing, which are very important to people? And when advertisers spend money, they're spending money so that they actually get a purchase. But how do we link that back to the ads that were shown to the user? Everybody with me? Yeah? Okay. Now, this is a very important segment because very often for privacy reasons or for other reasons, users may not have cookies. Cookies are what help you track, right? From the actual action by a user back to the ad they saw. But they may not have cookies or maybe noisy cookies or cookieless and so on, right? So in these situations, the problem we're solving here is, how do you really evaluate how effective a marketing campaign is? And also, by the way, if I have multiple campaigns, how do I attribute credit across multiple campaigns? That's the question we're addressing here. Okay? So, again, an online advertiser has a user is shown multiple advertisements. And so the user basically can be either looking at the TV screen or a video, can be looking at a radio advertisement, could be looking at probably a newspaper. So given all these channels, the question becomes, when the user is a happy camper and purchases things, right? You can see walking off with the bags. How do I relate these happy camper purchasers with any of these media? Was this a consequence of looking at the newspaper, listening to the radio, or watching a video or TV? That's the basic question, right? Okay. So our goal is to measure the effectiveness, right? Because any display advertising is like broadcasting out, right? And supposedly online advertising is more powerful than newspapers. Because when somebody reads the newspaper, you don't know what they're going to do. But supposedly when you watch a TV, internet ad, you supposedly can monitor what a person is doing and relate the two, right? That's a claim. So the bullseye is really how effective is this marketing campaign. Now, also, if a user performs a commercial action, how much of the credit for this conversion or action should be attributed when there are many, many channels, right? Each of these colored things corresponds to a different channel, right? And that's the attribution problem, okay? Now, just in terms of the data we are not quite looking at the 25 terabyte or beyond that Mike was referring to. We're looking at by the way, AOL, we got a really nice deal as part of the faculty award I got. I believe we're the only university group with unrestricted access to production data. And we are using their 1400-odd machine Hadoop cluster. And for this particular chunk, it's fairly compact data of about 4 terabytes coming through every day. Now, what we do is we use user preprocessed logs so that we extract two things. One is on a daily basis, what are the daily number of commercial actions, right? Like somebody bought something of a particular product. Okay, and then how many impressions were delivered on a per campaign basis? So you can see it's very aggregate, right? Because when you do behavioral targeting, you look at an ad, you look at the user action and link back individually. This is more aggregate. Now, by the way, many... Go ahead, question?
So I was just wondering, when you said the daily number of commercial actions, is that like instances where AOL has like a banner and therefore a cookie and they track someone buying something on Amazon? Is that what you're seeing there? What is the observation?
Yeah. The observation is the actual purchasing action.
Okay.
Yeah, we go all the way. Thank you for a very important clarification. Most often, many problems and papers in this area, they look at the ads and they look at the clicks. The clicks are surrogates, and they're not really the actual commercial actions. We have actually access to the actual actions where people bought something. Thank you. That's a very good. That's a big difference between most papers and what we're doing here. By the way, the reviewers in www commented positively on the fact that we're doing this. Yeah. So it's an aggregate level, not an item by item basis, but aggregate today what happened in terms of exposure versus how many people bought. That's the sort of connection. Now, notice that at any given time for the same product, you can have multiple campaigns which are running. So that is confusing because each campaign is a signal, but it becomes a noise to the others. So that is the big challenge here, right? Especially we've got several campaigns going on. So we are looking at about, over close to 4,000 campaigns with close to 1,000 products. Although for our purposes, we needed to pre-process and prune some of this stuff. So now, there are two things. One is, for all of you who are familiar with attribution, everyone familiar with regression and least squares here? Right? You always use R squared, right? To say how much of an impact does the independent variable have on the dependent variable, right? So the question is, but here what happens is we don't have a static situation, we have a dynamic situation. So we first build a model for the commercial actions and for campaign effectiveness using time series. So it's a dynamic model as base and not a static model. Okay, that's the first thing. So I'll go through this part pretty quickly because it's just building up and I'll get into the real core of the work pretty soon. So what we notice is, interestingly, there is a seasonal or weekly component in the daily number of sales. That's one interesting part. And what we look at is we get rid of the seasonal component and we focus on the trend, right, for the second part. Now, what we do is we look at the attribution to specific campaigns of any significant changes in the number of sales during a given advertising campaign, right? So here, we are just looking at campaigns overall. We are not saying, here is this ad, number of ads. We say, given this campaign, how much of a difference did it make? Not how many advertisement or impressions were looked at by anybody. Everybody with me? Because when you look at an ad campaign, you can say, hey, the campaign was present. Did it make a difference in the number of sales? Or you can say, how many advertisements did I show people, and how did the number make a difference to the actual purchasing action, right? This first pass, we're just looking at, did it make a difference and how much? So I'll go through this a little quickly. So we just built a simple dynamic linear model, if you think of state space models, right? To model the time series, to look at the whole seasonality and polynomial components. Okay. So, here what we did was we looked at the campaign duration and we looked at the start of a campaign and we said, hey, given the start of the campaign, during the period of the campaign, we could have different measures, right? We can say, you look at the total duration of the campaign. Did the total sales improve on average compared to the first day when I started? or did the sales increase on some large percentage of days? You can have different performance measures of success, right? So we used all these measures. And essentially, for this part, we assumed we used a EM algorithm. We fit it using a EM algorithm because this is, after all, a dynamic. You're trying to think in terms of a dynamic Kalman filter type of approach, right? So we estimated the parameters because we don't know the noise variances, so we just use simple EM to fit the parameters. Okay, everybody with me so far? Okay. Now, and so then you come to this conclusion that if you look at the distribution of campaigns, you look at this the sales percentage change, right? You'll see there's a positive change here, pretty positive. This is the right time distribution, which everybody is happy about. But AOL and the advertisers were not very happy about this left-hand side, where the reds correspond to a diminished percentage of sales after the campaign, right? So you think, how many of you think, wow, what a goofy advertiser? What do you think? So this was a big problem, right? Because AOL funded us, they thought, hey, they're going to show us great results of advertisers, and here's some bad news. Any thoughts? So, yeah.
I mean, are people coming in and advertising because they're losing market share, and so you're just kind of...
Very good response. So one case is they're already losing market share. By having a campaign, maybe you can boost it, so it's better than it would have been. So this is not an indicator. A similar instance is you take Christmas, the day after Christmas, when people are returning things. It'll go down, but if you advertise, maybe it'll go down not as much, right? Okay. So just, this is a standard sort of checking things on the way, right? Okay. Now we get into what is really new that we did, which makes a big difference, I think. And I was just talking to actually Phil Stark, one of the statisticians. He was very interested just as he walked out. So this is a full model with all the features linking actions and impression exposure, right? And I believe there is not quite literature like this. So the model features are, we model the impact of the number of impressions on the commercial actions, not it, okay. And importantly, we incorporate a decay factor of the impact of impressions on the commercial actions. Because if you think of people, right, if I look at an ad, maybe I'll act today, I buy something. But maybe I'll do this with a delay or a day or two, right? But maybe after a month I've forgotten the ad, right? So in the marketing literature, people have actually thought of a decay factor, but they haven't quite incorporated it in the dynamic fashion in which I'm going to show you just now. So the model assumptions are, of course, that the impressions are given to you in terms of data, right? You're counting them. Somebody gave them to you. And we're going to look at the gain coefficient. In other words, if you have a bunch of coefficients have a gain, right, of how it impacts each impression, what's the probability it will convert to a win. So we'll actually model these coefficients. We'll estimate them from the data, right? So now the other part of it is we're looking at multiple campaigns all together at the same time, which is complicated. And then these campaigns can be turned off and on, which makes it trickier. And so we use a fully Bayesian approach with Gibbs sampling, so that we're going to be looking at Bayesian Kalman filtering and sampling, okay? So I won't go through much of the details because I guess I don't have all that much time. But very quickly, what we say is the following. It sort of makes common sense. Think of ZCT, right? For every campaign, what we are saying is, hey, every campaign, there's some sort of a conversion of impressions into actions, right? Or purchases, Z to C. If some sort of estimate. If I add up all these, plus I have some noise, I actually see the total number of purchases people make, right? Everybody with me? So, and for each of these campaigns, I look at any given day, the number of purchases or estimated purchases as a function of what was the purchase last period times some decay factor, lambda, right? Because maybe if somebody bought something, it will be less today. Somebody bought something yesterday, maybe it will be less today. Plus, if somebody was shown a set of impressions today, there's some conversion factor, that's ZTC, right? So I'm looking at, I see a bunch of impressions XTC today. I have some gain coefficient ZTC. And then here is the estimated value of purchases yesterday. And then I multiply it by the decay factor, right? Plus some noise. Everybody with me? So, and I add them all up. So essentially, that's the type of model we have, right? Okay. So we're going to just, so all we now need to do is this model correct? Can I estimate these parameters lambda and C? And let me spell it out for you. So when I have multiple channels, multiple campaigns, I'm first looking at viewer memory persistence or decay, right? So here, any yt is the number of purchases that's equal to alpha t, which I'll tell you in a moment, some sort of baseline or the time series, which is independent of the impressions or ads somebody was viewing, plus some combination of a bunch of numbers, one for each campaign, plus some noise. Each campaign has got the number of, remember, we've got the number of attributions of the number of sales due to that campaign. So you look at the number of sales due to that campaign, ZTC, and if there is a decay of the impact of impressions on actions, so that last period, if I manage to sell ZT minus 1C, this period I'll sell fewer, right? It's a time series effect. Because persistence or memory, right? I'm going to forget it. Everybody with me? That's one component. Questions, doubts? Are you all with me? Yes? Okay. The second one is the dynamic coefficient, because when I see a certain number of impressions, XTC, that's a number for that particular campaign C, I have a gain coefficient ZTC, and I take the product of the two, and that changes the total number of actions or purchases that will be made, right? Attributions. Now, this coefficient is something that's random, which I need to estimate. I also need to estimate this too. So I need to estimate lambda C, I need to estimate ZTC, right? These are two things I need to estimate. Finally, I'm going to add up for multiple campaigns. I'm going to look at all these superimposition of all the effects of each of the campaigns. 3 pieces of the model, right? I'm going to solve this model. So, by the way, the last part of it is alpha t that we have here is like, if you think of regression, you always have a constant coefficient, right? Here, the constant coefficient is dependent on time. So this is the base model to account for the actions when there are no campaigns running, right? So you have a base model. Everybody with me? So I've got a base model for actions with no impressions being shown to people. And every time people see impressions, they're more likely to respond more positively, right? That's the components. So this bottom thing is that without seeing impressions, and the top is after you see the impressions, users buy more. And so the sum of both these, alpha t is without seeing impressions, this component here accounts for actions based on seeing impressions, and yt gives you the total number of sales that are made. That's the basic model. Okay? So the measure of attribution we used is like R squared, but it's different from R squared because we really look at so maybe you should look at this. We are looking at R squared as a measure of, R squared is always used to say what is the impact of the independent variable, of the independent variable on the dependent variable, right, for attribution purposes. So the only difference is, compared to traditional R squares, we're going to look at the sum of the square residuals here, not explained by advertising campaigns, right, and the base time series model over the residual total variance, which remains after you account for the base model, which is the time series, right? So you're accounting for the time series model, you get rid of it, and whatever remains, you're attributing it. That's the basic model here, okay? So this means that I'm able to account for the variance attribution or the proportion of variance described by each campaign separately, and that's what we're computing here. So that's the basic model we've developed. So here's the result that AOL was really very interested in. What they cared about was on the x-axis, you have all the R squareds, right? And in some sense, of course, R squared says, hey, we can be surer that this particular campaign really led to a positive implication, right, in terms of selling. So when I looked at on the y-axis, I look at all the products, and I see what percentage of these products, when I split them, had different R squared values or buckets, right? So you can see you start off with a percentage of them with relatively low R squared, but as you go to the right, the R squared keeps on increasing, so you can be more and more confident that these campaigns actually have a very positive impression on the sales. That's the basic model that we have. So that means the main thing for AOL is they're able to go to their customers and say, you know what, hey, we can now make certain that when you place an ad, or somebody places an ad, the performance of the ad can be guaranteed because we now have these computations which tell you how effective the ad campaign was, which they didn't have previously. And so this is about 20% of all ad campaigns. So it's a region that has not been staked out previously, because previously Google dominated with sponsored search, But now display advertising has become a big issue, and it's a dominant, it's sort of because I guess sponsored search has been worked on for a while. So display advertising has become a big issue. But now a segment of 20% of this new display advertisement, think of display advertisement as being half of the total spend, right? And of that 20% is a new gray, what is called gray inventory space. And we're able to solve this problem, on our way to solving this problem, I should say. So that's what's going on right now. I guess I'm just about the last few minutes. So the conclusion is we have a large-scale model with a linear superimposition of many campaigns, the dynamics, user memory persistence and decay effects, and also campaigns which are on and off. And it works. And the additional challenges in work in progress are how do you get a precise attribution to individual campaigns? In fact, Phil Stark, who's a statistician, and I were discussing just as he left. And how do you integrate this gray inventory with black inventory or definite behavioral targeting results? So that's the type of thing, next stages. So this sort of pretty much ends this particular talk, except I should say all these folks from all these companies are clearly, they are the ones who guide us in the work we do, and the students are the ones who do all the hard work, right? As you all know. I just want to add one little piece and I sign off, and that is to answer your question. You're asking, I believe you had a question for Laurent about, how useful is this and is it practical? Here's work we've been doing on text mining and topic guidance with SAP. So we looked at them at security services, at healthcare services, and also financial services. So this data was based on the UK security data set. So their goal was analyze this data set, and now anytime you see new data, tell us what can make us aware or be sensitive to issues concerned with security. So anyway, you have some details of the data, but this is a heat map where the red have very high density of topics and it falls off. So if you notice these topics, so each of these is a topic, and a topic is a word mixture with different probabilities of seeing words. But if you notice topic 6, they have Muslim, protest, Islam, a bunch of things, right? And then topic 14 has got IRA, police, government, Irish, and so on. So when we analyze this data, what we found was that the expert could look at this and say, aha, this is the first topic 6 is about Muslim terrorists, and topic 14 is about IRA terrorism or Irish terrorists. So they may have, both these have a lot of similar words, but the content of the document is different. So they were typing in London bomber, and they were very gratified when they showed them, look, are you talking about Irish terrorists or Muslim terrorists? So they're very happy about it. So that's the type of thing that you can actually have very differences. We also looked at the instrument of destruction in the financial crisis in the Valukas report. So the repo and the word mixture turned up, and they were very happy about that too. And in this particular case, you look at this document, right, and you extract the topic, exactly as Laurent was pointing out, you can see the topics 854, which is the British government, state politics in Afghanistan, are what feature. So certainly, I think the very, very practical problems that companies are very interested in. And by the way, this is only a starting point for our work because we go on to interactive search and to guide people as a search. So it's certainly very useful, I think, in many companies. Okay. So I think I'm going to stop here, and I want to thank Masood for the opportunity to present, and for my colleagues and all of you for patiently waiting on till the end of the day to hear me out.
Thank you so much.